Hello everyone. Today we talk about pulse width modulation. First we see the definition. Pulse width modulation reduces the average power delivered by an electric signal by converting the signal into discrete paths. In the pulse width modulation technique, the signal's energy is distributed through a series of pulses rather than a continuously varying signal. Now we straightly go to the explanation.
PWM we understand easily. So I take DC supply. I take 2 voltage, 10 voltage and 0 voltage. 10 voltage high in peak. You saw this. Then 0 volt Y on the x-axis. DC supply is constant. Next we saw the continuous waveform of DC supply. This is continuous DC supply waveform. In 10 voltage the waveform is here, and next fraction of second the waveform come to 0 volt. Next millisecond the waveform goes to 10 volt on off. The waveform goes continuously in one cycle. This is one waveform. On off on off on off is called pulse. How to know pulse width? On duration is called pulse width. On duration, off duration, on duration, off duration, on duration, off duration. This is called width. Now you know on off is pulse. Width. Duration is width. On off duration is width. Now the waveform of pulse width adjusted to increase and decrease is called pulse width modulation. So I wrote pulse width modulation equal to on and off. Next we saw the important point, duty cycle. Duty cycle equal to T on by T on plus T off. T on is 10 volt. T on duration. Next T on plus T off. Time period. Time period is T on duration plus T off duration. It's called time duration. Substitute this three value into 100%. Then we get a percentage value. The answer will be in percentage. Duty cycle equal to 50%. Now you ask, how duty cycle came 50%? One cycle equal to 100%. Now T on 50% 10 volt, T of 50% 0 volt. So the average voltage equal to 5 volt. Duty cycle 50%, 10 volt, 50% converted, 5 volt came. So the average volt is 5 volt. Now we talk about PWM technique use. PWM technique is applied in waveform. 10 volt on time, 0 volt off time. Duty cycle I give 10% in this waveform. Mean T on I give 10%, T off 90%. Total time period equal to 100%. T on 10%, T off 90%. For example, We assume LED with battery. 1 second equal to 1 second we give 10 percentage on time, 90 percentage off. To applied in the waveform, the result will be blink blank blink blank. So this 10 percentage is duty cycle. 10 volt equal to 100 percentage. 10 percentage equal to 1 volt. So average value equal to 1 volt. Pulse width modulate, we shortly tell change in pulse width with respect to time. We have a average voltage.
And finally, we saw the applications. First, dim lights control brightness, and second, speed control of motors, and third, computer laptop dimming, brightness adjust increased and decreased. This is the application of PWD. Thank you.